Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay.
Now let's try to solve one more question. Let's say, given an array, calculate max element of an array. It's a very simple question. Why I'm helping you to do this? Because I want you guys to be a bit accustomed to the pattern of arrays and recursion. For example, if the array is 3, 1, 6, 9, 21, 0, minus 1, the answer should be 21. Okay. Now, and let's say you have to solve this problem recursively. The thing is, if you would have solved this problem iteratively, what would have been the agenda? Iteratively, you will go to every single element, read every single element, and then only you will be able to come to an answer, right? If I want you to solve this iteratively, then without reading the whole array, you can't calculate the max, right? So if you want to calculate the maximum of the array, you have to at least read the whole array, right? Now, we already know how to read the whole array in recursion. Let's see if we can solve something there. So let's say I write a function f of arr, idx. You have to always just put some brain here that what your problem will actually denote. I will say the function returns maximum element in the range idx to n minus 1, right? What this function will actually do is it is going to return.
So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video.
The maximum element from the index idx to n-1. For example, if I call for f of arr comma 5, it is going to return the maximum element from the fifth index to the last index. In this range, whatever is the maximum element, it will return that. So originally, what we will call for? We will call for f of arr comma 0 because we want the maximum from the 0th index to the last index. That will be the original call from main, right? This will be call from main. If anyhow we are able to successfully implement this function somehow, then from the main I will call for this, right? Okay, cool. Now let's see how can we solve this question. Now just think about it. If let's say this is the array, let's say this is idx. I want the maximum element in this range. Forget about all of this. You want the maximum element in this range. If you want the maximum element in this range, the only element that I have access to is 9. I can currently just access 9, right? Because index is pointing to 9. I can just access 9. Rest of the elements I have to manually go and access, right? So what should the task delegation say? The task delegation should say that, hey man, I don't know how to calculate the maximum element. Looks pretty cumbersome. All I can do is I have access to the current element. If you want me to do something with that, I'm okay with it. I just have access to the current element, right? You have in one function call, you have access to the current element. If you want us to do something with that, we are good to go. Otherwise, I'm not sure if I'll be able to pull this off. So we can say, okay, don't worry. You have the access to the current element. How about if somebody else gives you the maximum element of this range? You wanted to calculate maximum element of this range, right? Forget about this. Wanted to get the maximum element of this range. How about if somebody gives you the maximum element of this range? If somebody gives you the maximum element of this range, then what will happen? You have the maximum element m of this range and you have access to your current element. Maybe let's say this current element was 99 or it was -9, whatever it is, or just 9. You have the access to the maximum element of the remaining elements. What you can do, you can compare that maximum with your current element, that which one is bigger. If your current element is bigger, then the answer of the whole range is your current element. If your maximum is bigger, then the answer of the whole range is the maximum element. So what I'm saying is, if f or arr comma idx can get you the maximum from the index idx to the last index, how about you go and calculate arr comma idx plus 1. And what is this? We assume we delegated the task for calculating maximum in the remaining elements, and we got it. That means we will assume that the function works correctly for arr comma idx plus 1. We are going to assume it. Of course, the assumption internally actually makes the call, right? But we are going to just assume it that this particular term works for us. If this particular term works for us, what you can say is the answer of f of arr comma idx will be maximum of, compare the current element with this. This is going to return you the maximum of the remaining element. You compare maximum of the remaining element with the current element. Whosoever is maximum in this particular comparison is the answer for arr comma idx. So let's see. Let's say initially from the main you will call for f of 0, right? F of ARR comma 0. You will call for f of ARR comma 0. You want the maximum from 0 to the last index. I don't know who is the maximum from 0 to the last index. I will say, please go and calculate maximum from the first index to the last index. Please go and calculate this value. And whatever you get, you can compare with the 0th index. Okay. Now, again, you want to calculate the maximum from the first index to the last index. I don't know how to do it. You will delegate the task that, hey man, please give me the maximum from the second index to the last index. Same thing. F of ARR comma 3, right? You need to get the maximum from the third index to the last index. Same thing. ARR comma 4, ARR comma 5, right? 4, 5, and F of ARR comma 6. You will reach F of ARR comma 6. Now this is the last element. Now just think about it. What is the simplest answer in this problem you can solve? If the array is of single length, it's a single length array. If it's a single length array, then the answer is that single element only, right? If you just have a single element in the array, that's the maximum element. What is ARR comma 6 representing? ARR comma 6 represent, you want to get the maximum from the 6th index to the 6th index. That means in your observation, you just have a single element. If you just have a single element, that element is your answer, right? So forget about everything. In this range, the answer is -1. So what will happen? You are going to return -1 here. And what is ARR comma 5? You wanted the answer from 5th index to the last index. You have the maximum of the remaining element. What is the maximum of the remaining element? -1. You got the maximum of the remaining element, -1. You compare it with the current element, 0. Which one is bigger, 0 or -1? 0. So here, you are going to return 0. Now, you are at index 4. You wanted for calculating 4 to n-1, you said that, please give me the maximum from 5 to n-1. You have the answer for maximum of this range. What is the maximum of this range? 0. You compare 0 and 21. Which one is better? 21. So you return 21. Now you are at 9, that is index 3. You wanted the maximum of the remaining array. It's 21. You compare 21 with 9. Which one is bigger? 21. So you return 21 here. And you are again back. Okay. Now you are at index 2. To calculate 2 to n-1, the maximum of this range, you asked for 3 to n-1. And now you have the answer for 3 to n-1, 21. The maximum element in this range is 21. So you compare 21 and 6. Which is bigger? 21. So you again return 21. Here as well, answer of the remaining range is 21. You compare 21 and 1. You return 21. And now if you carefully see, this was our biggest problem. That I wanted the answer of the maximum in the range 0 to n-1. To calculate that, I said that please give me the maximum of the remaining array. Maximum of the remaining array is 21. Compare 21 and 3, which is bigger? 21. So you return 21 and the answer is 21. That's it. So you can see, this is the recursive relation. If I will just directly write it, it should be done for us. And this is the base case. If you are at the last index, that means you just have a single element in observation. In a single element, the answer is that element only. Let's implement this. And you can see a similar structure we are following. Okay. Again, same thing, public static int f. What are the parameters? Array and index. So array, index. What's the base case? The base case will be if index is at the last index, arr.length -1, then whatever is the element at the last index is your answer. ARR of ARR or return ARR of IDX. Okay. That means If you are at the last index, it is your answer. But if you're not at your last index, then what's your answer? Max of this value. So math dot max of ARR at IDX, comma f of ARR, comma IDX plus 1. That's it. See, whatever I said, I wrote the same thing. Nothing more, nothing less, right? So I'll just copy the input from here. Let's get some more values. -1, 4, 5, 22, 34, 6, 7, -4, 0. Okay. And whatever is the return value of f of ARR, comma 0, we will return that. So if you run it, 34, and you can see 34 is the maximum value, right? As simple as that. And in a similar way, maybe somebody asks you for the sum of an array. If you want to calculate sum of the array, I believe now we can directly write a relation. If let's say you want to calculate sum of array recursively, then what you can do, you can say, let's write a function ARR, comma IDX. This function returns sum of all elements in the range IDX to n minus 1, right? How can we get the sum of all the elements in the range IDX to n minus 1? If somehow somebody can give me sum of all the elements from IDX plus 1 to n minus 1, I will add the current element to it. That's it. This is the recurrence relation for sum of the array, right? And what will be your base case? If index is n minus 1, that means you just have a single element under observation. The sum is equal to that single element only, right? So you can see different type of problems you can actually solve here. Sum of the array, maximum of the array, minimum of the array, anything you can actually solve. I hope this problem makes sense to everyone.